Imagine waking up tomorrow morning, checking your phone like any normal day, and suddenly seeing headlines everywhere claiming that humanity may have just discovered evidence of alien life, not in some Hollywood movie, not in a conspiracy theory, but through the most powerful space telescope ever built by humans. Now, most people saw those headlines, got excited for a few minutes, and moved on. But scientists did not, because hidden inside this story is something genuinely unsettling, something that could completely change how we understand life in the universe. More than 120 light years away from Earth, orbiting a distant red dwarf star, a planet called K218b, appears to contain a strange molecule in its atmosphere, a molecule that, here on Earth, is associated with living organisms. And when the data came back from the James Webb Space Telescope, even researchers were shocked by how strong the signal appeared to be. The number making headlines around the world was 99.7%. Some people immediately assumed that meant alien life had basically been confirmed. Others dismissed the entire discovery as media hype. But both reactions missed the real story entirely. Because this is not just about one molecule floating above an alien ocean world. This is about the possibility that, for the first time in human history, we may be detecting a genuine biosignature on another planet, a possible fingerprint of life beyond Earth. And if that sounds dramatic, it should. Because if this signal turns out to be real, then humanity may have quietly crossed one of the biggest scientific thresholds ever imagined. But here's the part nobody is explaining correctly. The moment this discovery appeared online, the internet did what it always does best. It exploded. Headlines started claiming that the James Webb Space Telescope had found alien life. Social media turned the story into proof that we are no longer alone. Some posts even treated the discovery as if scientists were already preparing to announce first contact. But the real scientific story is far more complicated and honestly far more interesting. What researchers actually detected was something called a possible biosignature. A biosignature is not an alien organism, an alien city, or an alien spacecraft. It is simply a chemical clue that might be connected to biological activity. In this case, the molecule attracting attention is dimethyl sulfide, or DMS, found in the atmosphere of K218b. Here on Earth, DMS is strongly associated with life, especially microscopic marine organisms living in our oceans. That is why scientists became excited. If the same molecule exists on another planet, it raises an enormous question. Could something alive be producing it there too? But there is a massive difference between saying this could be a biosignature and saying aliens have been discovered. Those are not remotely the same thing. A possible biosignature means scientists found a clue that deserves further investigation. Alien life confirmed would require overwhelming evidence, repeated observations, independent verification, and the elimination of every possible non-biological explanation. Science does not jump from curiosity to certainty overnight, especially when the stakes are this enormous. The problem is that headlines rarely reward patience. Scientists detect possible atmospheric chemical linked to biology under specific conditions does not generate millions of clicks. But James Webb found alien life certainly does. So the nuance disappeared almost immediately. Even the famous 99.7% figure was widely misunderstood. Many people assumed it meant scientists were 99.7% sure aliens exist on this planet. That is not what the number means at all. The percentage only refers to confidence that the telescope may have detected the chemical signal itself, not confirmation of life. Those are two very different things. And this is where the scientific community became both thrilled and cautious at the same time. Researchers understand how extraordinary this observation could be if confirmed. But they also understand the history of science is filled with signals that looked groundbreaking at first and later turned out to have simpler explanations. Scientists are trained to be skeptical, especially when a discovery feels almost too exciting to be true. In fact, the more revolutionary a claim is, the more evidence is required before the scientific world accepts it. That caution is not weakness. It is exactly why science works. Still, despite all the careful language and uncertainty, one thing is undeniable. The fact that humanity is even capable of detecting possible biological chemistry on a planet 120 light years away is astonishing. Just a generation ago, this would have sounded impossible. Today, it is becoming reality. Now let's travel to the world at the center of this mystery, a planet known as K218b. This is not a rocky Earth twin with blue skies, green forests, and continents waiting to be explored. K218b is something far stranger, something that may not even resemble any world in our own solar system. Located around 120 light years away in the constellation Leo, this distant planet orbits a small, dim, red dwarf star. Unlike our sun, red dwarfs are cooler and darker, casting a deep reddish glow across nearby worlds. If you could somehow stand beneath the skies of K218b, the light above you would likely feel eerie and unfamiliar, like a permanent sunset stretching endlessly across the horizon. And then there is the planet itself. K218b is enormous compared to Earth. It is about 2.6 times wider than our planet and carries roughly 8 times Earth's mass. That means the gravity there could feel crushing, depending on where you stood and what the planet's surface is actually like. But here's where things become truly fascinating. K218b sits inside what scientists call the habitable zone of its star, the region where temperatures may allow liquid water to exist. In simple terms, it is not too hot and not too cold. The cosmic sweet spot where life might have a chance. Yet this world is nothing like Earth. Scientists believe K218b could belong to a bizarre category called a Haitian world, short for hydrogen and ocean. Imagine a planet covered almost entirely by massive global oceans, stretching farther than anything on Earth. No continents, no beaches, just endless dark water beneath a gigantic atmosphere rich in hydrogen gas. Picture waves larger than mountains moving through a planet-wide ocean under dim red light. Above that ocean hangs a thick atmosphere so dense and deep that the sky itself might appear hazy and permanently shadowed. Sunlight from the red dwarf star would struggle to penetrate the upper layers, creating an alien world that feels more like science fiction than reality. Compared to Earth, K218b may be wetter, heavier, darker, and far more extreme. But compared to Neptune, it may actually be surprisingly temperate. It exists in a strange middle ground between rocky planets and gas giants, unlike anything humans have ever visited. And this is exactly why scientists are obsessed with it. For years, astronomers searched mainly for planets that looked almost identical to Earth, but K218b challenged that thinking completely. If life can survive on a world like this, beneath thick alien atmospheres and endless oceans, then the universe may contain far more habitable environments than we ever imagined. Because suddenly, life would no longer require an Earth clone. It could emerge in places far stranger and far more common than humanity ever expected. At the center of this entire story is a molecule most people had never even heard of before this discovery made headlines. It is called dimethyl sulfide, or DMS. And strangely enough, this tiny chemical may become one of the most important molecules in the history of science. Now, the name sounds complicated, but the idea behind it is actually very simple. Here on Earth, dimethyl sulfide is produced almost entirely by living organisms, especially microscopic marine life floating near the surface of our ocean. Tiny plankton release DMS into the atmosphere as part of their natural biological processes. In other words, life creates it, and that matters enormously. Because when the James Webb Space Telescope analyzed the atmosphere of K218b, scientists found a signal that appears to match this exact molecule. To understand why researchers became so excited, imagine walking past a house and seeing smoke rising from the windows. You cannot immediately prove there is a fire inside, but smoke strongly suggests that something is burning. That is essentially how scientists view DMS. It is like smoke for biology. The molecule itself is not proof of alien organisms. But on Earth, every time we find significant amounts of DMS, life is involved somehow. That makes it one of the most intriguing potential biosignatures scientists have ever searched for on another world. And this is what makes DMS very different from molecules like methane. Methane can absolutely be connected to life, but it can also form through non-biological processes like volcanic activity, underground chemistry, or geological reactions. Scientists have found methane throughout the solar system in places where no life exists at all. DMS is different because researchers currently know of very few natural, non-biological ways to produce it in large quantities. That immediately makes the signal more interesting and potentially more significant. Of course, there is still an important catch. Just because scientists do not currently know another explanation does not mean another explanation does not exist. Nature has surprised humanity many times before. Unknown chemical reactions could still mimic the same signal. That is why researchers remain cautious, even while acknowledging how unusual this discovery is. But think about what this means for a moment. Humanity has now reached a point where we can analyze the atmosphere of a planet 120 light years away and identify molecules that on Earth are linked to living ecosystems. That is extraordinary. For thousands of years, humans stared at distant stars and wondered if life existed out there somewhere. Today, for the first time, we may be seeing not the life itself, but perhaps the chemical breath of an alien world. So how did humanity detect a possible sign of life on a planet so far away that even light takes 120 years to travel from there to Earth? The answer sounds almost impossible. Yet it is real science happening right now aboard the most powerful space telescope ever built, the James Webb Space Telescope. But here's something important most people misunderstand immediately. Webb is not taking pictures of alien planets the way your phone takes pictures of people. It is doing something far more sophisticated. It is reading invisible patterns hidden inside light itself. Imagine staring at a tiny flicker of light from across an enormous cosmic ocean. That light began its journey before smartphones existed, before the internet became common, before many people watching this video were even born. For 120 years, it traveled silently through interstellar space, until finally reaching the mirrors of the James Webb Telescope. And hidden inside that ancient light was information. Here is how scientists extracted it. As K218b passes in front of its star, a small amount of starlight filters through the planet's atmosphere before continuing toward Earth. This event is called a transit. Now, if that atmosphere contains gases or molecules, they absorb specific colors, or more accurately, specific wavelengths of light. Different chemicals absorb different patterns. It is almost like every molecule leaves behind its own invisible barcode. Scientists call these patterns spectral signatures, or light fingerprints. This technique is known as infrared spectroscopy, and it is one of Webb's greatest strengths. Unlike the human eye, Webb sees primarily in infrared light wavelengths, invisible to us, but extremely useful for studying planetary atmospheres. When Webb analyzed the light coming through K218b's atmosphere, it detected unusual absorption patterns, and among those patterns appeared something incredibly intriguing, a signal consistent with dimethyl sulfide, the molecule associated with biological activity on Earth. Think about how astonishing this really is. Scientists are not physically touching the planet. They are not collecting samples. They are decoding chemistry from tiny distortions in ancient starlight crossing unimaginable distances through space. The precision required is almost absurd. The atmospheric signal from a distant exoplanet is incredibly faint, sometimes representing changes in starlight smaller than a fraction of a percent. Yet Webb is sensitive enough to detect these microscopic variations and reconstruct the chemical makeup of an alien atmosphere from them. It is less like taking a photograph and more like listening to a whisper from across the galaxy. And what makes this moment so historic is that humanity has never before possessed a telescope powerful enough to study distant worlds with this level of detail. Just a decade ago, detecting possible biosignatures on another planet sounded like a dream for future generations. Today, it is happening in real time. Now we need to talk about the number that caused most of the confusion around this discovery, 99.7%. Because the moment people heard that number, many assumed scientists were saying there is a 99.7% chance alien life exists on K218b, but that is not what the data means at all. And honestly, this misunderstanding spread faster than the actual science. What researchers are saying is that they are roughly 99.7% confident they detected a signal consistent with dimethyl sulfide, or DMS, in the planet's atmosphere. That confidence applies only to the detection of the chemical signature itself. It does not mean scientists are 99.7% certain aliens exist there. Those are completely different claims. To understand this better, imagine hearing footsteps upstairs in your house late at night. You might become highly confident that someone or something is making noise up there. But that does not automatically tell you who or what caused it. It could be a person, a pet, pipes expanding, or something else entirely. That is essentially where science stands right now with this signal. Researchers believe they may be detecting the footsteps of DMS, but proving the actual source of that signal is a much bigger challenge. Scientists measure confidence using something called sigma levels, and while the math behind it can get complicated, the basic idea is surprisingly simple. The higher the sigma, the lower the chance the signal is, just random noise or an accident. The current DMS detection is considered roughly a 3 sigma result. That corresponds to about 99.7% confidence. In everyday life, that sounds incredibly convincing. If your weather app said there was a 99.7% chance of rain, you would probably grab an umbrella immediately. But science, especially revolutionary science, demands much stricter standards. For discoveries considered truly definitive, physicists usually require a 5 sigma level of confidence before making official claims. A 5 sigma result means the odds of the signal being a random fluke are extraordinarily tiny. This was the standard used when scientists confirmed the existence of the Higgs boson particle. So while a 3 sigma signal is exciting, it is not the scientific equivalent of shouting case closed. It is more like science saying, this is extremely interesting. We need to investigate further. And that distinction matters enormously because history has taught scientists to be careful. There have been previous moments where unusual signals looked groundbreaking at first, only for later observations to reveal more ordinary explanations. Space is complicated. Planetary atmospheres are complicated. Even telescopes this advanced can produce data that requires years of verification. That is why responsible scientists are approaching this discovery with 2 emotions at the same time: excitement and skepticism. Excitement because detecting a possible biosignature on another world would be one of the greatest discoveries in human history. Skepticism because extraordinary claims require extraordinary evidence. Still, even with all the caution, one fact remains astonishing. Humanity has now built instruments sensitive enough to detect potential chemical traces of life from a planet orbiting another star over 700 trillion miles away. And whether this signal ultimately turns out to be biology or not, that alone marks the beginning of a completely new era in the search for life beyond Earth. But now comes the most important part of the entire story, the part that separates science from speculation. What if the signal is not evidence of life at all? That question is exactly what scientists around the world are asking right now. And surprisingly, many of the researchers most excited about this discovery are also the first people trying to prove themselves wrong, because scientists are trained to doubt exciting discoveries. That might sound strange to people outside science, but skepticism is not a weakness in research. It is the entire reason scientific discoveries become trustworthy in the first place. The bigger the claim, the harder scientists try to tear it apart before accepting it as real. And when the claim involves possible alien life, the level of caution becomes extreme. Even though the James Webb Space Telescope detected a signal consistent with dimethyl sulfide in the atmosphere of K218b, researchers still need to rule out many other possibilities before drawing any major conclusions. One possibility is unknown chemistry. Just because scientists currently do not know a non-biological process that produces large amounts of DMS does not mean nature cannot surprise us. The universe has repeatedly shown that it is capable of chemistry stranger than humans originally imagined. An exotic atmospheric reaction on K218b might mimic the same signal without any life being involved at all. Another possibility is instrument noise. Webb is unbelievably powerful, but it is still measuring incredibly faint signals across unimaginable distances. Tiny distortions, random fluctuations, or data processing artifacts can sometimes create patterns that look meaningful even when they are not. Detecting exoplanet atmospheres is one of the most delicate forms of astronomy ever attempted. Then there are atmospheric effects themselves. Planetary atmospheres are chaotic systems filled with pressure changes, radiation interactions, temperature layers, clouds, and chemical reactions. Sometimes molecules overlap spectrally in ways that can confuse observations. A completely different combination of gases could potentially imitate the fingerprint scientists currently associate with DMS. And this is exactly why science moves slowly. The public often wants instant answers. Either aliens exist or they do not. Either the signal's real or fake. But real science almost never works that way. Instead, discoveries go through years of testing, criticism, repeated observations, and independent analysis before researchers become confident enough to make stronger claims. That process can feel frustrating, especially when headlines make it sound like the answer is already obvious. But caution is what protects science from fooling itself. In fact, astronomy has experienced moments like this before. There have been signals in the past that initially looked revolutionary. Mysterious radio bursts, strange atmospheric chemicals, even possible signs of life on Mars, only for later studies to reveal more ordinary explanations. Those experiences taught scientists an important lesson. Excitement alone is not evidence. So right now, the scientific community is entering a critical phase. More observations of K218b will be needed. Other telescopes will study the planet. Researchers will build more advanced atmospheric models and search for additional biosignatures that either strengthen or weaken the case for life. And honestly, that uncertainty is part of what makes this moment so fascinating. Because humanity may be standing at the edge of one of the greatest discoveries in history, or witnessing a reminder of how difficult the universe is to understand. Either way, the search itself is changing science forever. What kind of life could exist there? If a world like K218b truly hosts life, it would almost certainly not look anything like life on Earth. And that is where things get truly fascinating, because the rules of biology may still apply, but the outcomes could be completely alien. Scientists think this planet could be a Haitian world, meaning a place covered by a vast global ocean beneath a thick, hydrogen-rich atmosphere. No continents, no forests, no land animals walking across solid ground. Just an endless, deep, dark ocean stretching across an entire planet. Now compare that with Earth's own deep oceans. Even here, in complete darkness and crushing pressure, Life thrives in ways that feel almost unreal. Strange fish with glowing bodies, microbes surviving without sunlight. Entire ecosystems built around chemistry instead of solar energy. And even more extreme are hydrothermal vents at the bottom of Earth's oceans. These are cracks in the seafloor where superheated, mineral-rich water erupts from inside the planet. And around these vents, life exists without sunlight at all. Microbes feed on chemical energy instead of sunlight, forming the base of entire ecosystems in what should be one of the most hostile environments on Earth. Now imagine that idea, but scaled up to an entire planet. On a Haitian world, life would not be limited to shallow seas or small vent systems. It could potentially fill vast layers of ocean thousands of kilometers deep. If DMS really is being produced there, it could be coming from microbial life floating in those dark alien waters, adapted to conditions we can barely imagine. But there is also a more intriguing possibility. Life there might not follow Earth's blueprint at all. It could use completely different chemistry, different energy sources, and different biological structures. We tend to assume life means cells, DNA, and oxygen-based systems. But in an environment so different from Earth, evolution could have taken an entirely different path. And that is what makes this moment so powerful. We are not just asking if life exists elsewhere. We are asking what life even means when the environment changes completely. Why this discovery changes everything. Whether the signal turns out to be biological or not, something important has already changed. Humanity is no longer guessing in the dark. We are now actively studying planets that might be capable of supporting life. And that alone forces us to rethink our place in the universe. For most of human history, Earth was assumed to be unique. Life was seen as rare, fragile, and possibly limited to a single planet. But if even one world, like K218b, shows signs of biological chemistry, it changes everything. Because it suggests a powerful idea. Life might not be a miracle that happened once. It might be a natural outcome of the universe itself. This is where concepts like the Drake equation become important. In simple terms, it is an attempt to estimate how many intelligent civilizations might exist in our galaxy. Even if we do not know the exact numbers, discoveries like this push the equation in a very different direction. They suggest that planets capable of hosting life might not be rare at all. They might be common. And that leads directly into one of the biggest questions in science, the Fermi paradox. If the universe is so large and potentially full of habitable worlds, then where is everybody? Why haven't we seen clear signs of other civilizations yet? This discovery does not answer that question, but it makes it more real than ever before. Because if life can emerge more than once, in completely different environments, then the universe may be far more alive than we ever imagined. Not just a collection of empty stars and silent planets, but a vast system where biology is constantly trying to take shape wherever conditions allow it. And that realization is bigger than any single detection. It changes how we think about Earth, about life, and about our own significance in the cosmos. Maybe we are rare. Maybe we are common. Or maybe we are just one example of something the universe does again and again. Either way, we are now close enough to start finding out what happens next. Right now, this discovery is not an ending. It is the beginning of a long scientific investigation that could take years to fully resolve. The signal detected in the atmosphere of K218b is only one piece of a much larger puzzle. Scientists will now return to this planet again and again, using new observations to confirm whether the same chemical signature consistently appears or disappears over time. Because in science, a single detection is never enough. Real confirmation requires repetition, verification, and independent analysis from multiple teams around the world. The James Webb Space Telescope will continue studying this world, but it will not work alone. Other ground-based observatories and future space missions will also join the effort, each bringing different instruments and techniques to study the same atmosphere from different angles. Scientists will also compare K218b with other similar exoplanets. If similar chemical signatures are found elsewhere, it could suggest a broader pattern across the galaxy. If it is unique, that might make it even more interesting. At the same time, researchers will refine their atmospheric models, testing every possible non-biological explanation. This is slow, careful work. Not because science is uncertain by nature, but because certainty must be earned, not assumed. And there is one more important point. Even if everything goes perfectly, confirmation of what this signal truly represents may take years, not months. That is simply how long it takes to eliminate doubt when dealing with data from a world 120 light years away. But something even bigger is coming. Future telescopes, even more advanced than Webb, are already being planned. These next-generation observatories will be capable of studying exoplanet atmospheres in even greater detail, potentially detecting multiple biosignatures at once instead of just one. Each new instrument brings humanity one step closer to answering a question that has followed us since the beginning of time. For thousands of years, humans have looked up at the night sky and asked a single question again and again. Are we alone? We told that question in myths, we wrote it into philosophy, we built entire belief systems around it, and for most of history there was no way to answer it. Only wonder, only imagination. But now, for the first time, science is beginning to reach far enough to turn that question into something testable, something measurable, something real. We are no longer just staring at the stars. We are studying them. We are analyzing their planets. We are reading the chemistry of worlds we may never physically touch. And somewhere inside that data, on a planet like K218b, there may be a clue that changes everything we thought we knew about life itself. Maybe it is just chemistry. Maybe it is a false alarm. Or maybe, just maybe, it is the first whisper of biology beyond Earth. For now, we do not have the final answer. But we are closer than we have ever been before. Because for the first time in history, science may finally be approaching a moment that once belonged only to dreams. And somewhere tonight, beneath an alien ocean 120 light years away, something may already know we exist.